Your application is getting hammered. Traffic spiked 3 minutes ago. You immediately triggered auto-scaling to add more instances. The API returned success. The dashboard says scaling in progress, but your error rate is still climbing. Users are timing out. You refresh the instance list. Still the same count. You check again 30 seconds later. Still scaling. A full minute passes. Then 2. Finally, at the 3-minute mark, new instances appear. They boot. Health checks pass. 4 minutes total from decision to serving traffic. 4 minutes feels like an eternity when your service is melting down in real time. This is control delay, the gap between issuing a command and seeing the result. Cloud platforms are fast, but they're not instant. And that delay, measured in seconds or minutes, is long enough to cause real damage if you're not expecting it. So what is control delay? Control delay is the time gap between when you execute a control action and when that action takes effect. You click, you wait, you call an API, you poll for completion, you update a configuration, you watch for propagation. The confusion comes from the interface. When you provision a VM through the console, you get an immediate response. Instance I, ABC, 1, 2, 3, creating. The UI makes it feel instant, but creation isn't complete, it's started. That instance needs to be scheduled on physical hardware. The image needs to be loaded, the network needs to be configured, the boot sequence needs to run. All of that takes time. Control delay has 2 components, acknowledgement time and execution time. Acknowledgement happens fast. The cloud provider receives your request, validates it, and confirms it's queued. That's usually sub-second. Execution takes longer. The provider actually performs the work you requested. That can range from seconds to minutes, depending on what you're asking for. The dangerous assumption is treating acknowledgement as completion. The API returned a 200 OK response, so it's done, right? No. The API confirmed it received your request. The work is queued. Now you wait for it to actually happen. Control delay isn't arbitrary slowness. It comes from the fundamental realities of distributed systems and physical infrastructure. Resource provisioning involves actual work. Spinning up a virtual machine means allocating CPU and memory on a physical host, attaching virtual storage, configuring networking, loading an operating system image, and running boot processes. Even with modern hypervisors optimizing every step, this takes tens of seconds minimum. Launch 100 instances simultaneously. Now there's queuing, scheduling, and resource allocation coordination happening across a fleet of physical servers. Minutes, not seconds. Eventual consistency creates delay by design. When you update a DNS record, that change needs to propagate to DNS servers worldwide. When you modify an S3 bucket policy, it needs to distribute to every access point in the region. When you update a DynoDB item, replicas need to sync. These systems don't wait for global consistency before confirming you're right. They'd be too slow. Instead, they confirm the right locally and propagate asynchronously. You get speed on the write, but delay on the read. Other systems might see stale data for seconds or minutes. API rate limiting and queuing add delay during high traffic periods. Cloud providers process millions of API requests per second. When demand spikes, requests get queued. Your delete operation might wait in line behind thousands of other operations. Usually this is milliseconds. During an outage, when everyone's trying to modify their infrastructure simultaneously, it can be seconds or longer. Geographic distribution creates propagation delay. Update a CloudFront distribution. That configuration needs to push to edge locations worldwide. That's not instant. It's a coordinated deployment across hundreds of points of presence. The provider gives you a progress indicator showing propagation status because they know it takes time. And physical reality imposes hard limits. You can't create a server faster than the boot process runs. You can't attach storage faster than the storage controller can configure it. You can't establish network connectivity faster than routing protocols can converge. Software can't work around hardware timing constraints. Control delay turns from annoying to dangerous when you build systems that assume instant execution. The classic mistake: sequential operations that don't wait for completion. You create a VM, then immediately try to attach a disk to it. Except the VM isn't fully created yet. The API confirmed it's creating, but it's not ready. Your disk attachment fails. Why? You didn't account for the delay between command and readiness. Automated remediation breaks when delay isn't factored in. Your monitoring detects a problem. Automation triggers a fix: restart the service. The restart command succeeds. Monitoring checks again 2 seconds later. Problem still exists. Automation triggers the fix again and again. Now you have 5 restart operations queued, all trying to fix the same issue, each one executing with delay. You've created a chaotic loop because you didn't wait for the first fix to complete. Incident response becomes chaos when you're fighting delay. The database is struggling. You scale up to a larger instance type. API confirms. You keep refreshing. Still the old instance type. Another 30 seconds passes. Still the old type. You wonder if it failed. You trigger it again. Now you have 2 scaling operations racing each other. One completes. Then the other executes, undoing what you just did. Delay creates confusion that leads to mistakes. Dependency chains amplify delay. You need to deploy an application that requires a VPC, subnets, security groups, load balancers, instances, DNS records. Each step has delay. Each step must complete before the next begins. Total time from start to working application: 4 minutes minimum, assuming nothing goes wrong. Try to parallelize too aggressively and dependencies fail because resources aren't ready yet. The worst scenario: making critical decisions based on stale data. You check resource utilization, it's at 40%. You decide to scale down, but that metric is 90 seconds delayed. Actual current utilization is 85% and climbing. Your scale down command succeeds. 30 seconds later, it executes. Now you've reduced capacity exactly when you needed to increase it. Delay in observability plus delay in control equals disaster. You can't eliminate control delay, but you can design systems that work with it, instead of fighting it. Poll for completion. Don't assume success. When you issue a control command, implement polling logic that checks status until the operation actually completes. Don't move to the next step until the current step reaches a terminal state, succeeded or failed. Build in wait states for dependency chains. Add explicit waits. Poll for health checks. Verify readiness before proceeding. Understand eventual consistency windows for the services you use. DNS changes. Budget 60 seconds for propagation, even though the API returns instantly. IAM policy updates. Give it time before assuming new permissions are active everywhere. Design for asynchronous operations. Stop treating cloud operations as synchronous function calls that block until complete. Treat them as asynchronous operations that return handles you poll. Increase observability into operation state. Don't just log scaling triggered. Log progress stages until scaling complete. Visibility into the delay helps you understand what's happening and whether progress is normal or stalled. And most importantly, test your operations under delay. Introduce artificial delay in testing environments. See what breaks when provisioning takes twice as long as usual. Find the places where your code assumes instant execution and fails when reality doesn't cooperate. Control delay is the gap between command and execution, between intent and reality. Cloud platforms are fast, but distributed systems have timing constraints that can't be eliminated. The organizations that succeed in cloud aren't the ones fighting delay. They're the ones who design with it in mind. You've got control, sure, but that control takes time to manifest. Factor that time into your architecture, your operations, and your incident response. Otherwise, you're building on an assumption that breaks the moment things get complicated. Coming up in this series, control under stress. What happens to your control when systems are degrading and every decision matters? And remember, the API said success, but success is still in progress. See you next time.